Great pleasure to be here and talking about enterprise virtualization. Many thanks to the SNUG organizers for providing me with this opportunity. And many thanks to all of you for showing up despite of the rain. So, is virtualization a fairy tale or a fairy tale of virtualization? What I feel is that all of us got introduced to the concept of virtualization by our grandmother. When our grandmothers told us fairy tales. Fairy tale is nothing but there are virtual characters in the fairy tales, all of these fairies and witches and whatnot. These people are sort of modeled from real life people, and then the kid also is told that this is not real, this is something virtual, this is not really real, but then there are a lot of things to learn from the fairy tale. So there is a lot of mapping that happens between real life and virtual life in the fairy tale. And this is where everybody really learned about virtualization. This is where we started learning about virtualization. So all of us are really intimately familiar with virtualization. It is just that we don't know that it is called virtualization. And this is a very interesting frame. First of all, it's a frame from a movie called Snow White and Seven Dwarfs by Walt Disney. And this is a first cartoon feature film, that full-length feature film that was developed. And just think of the degrees of virtualization involved here. First of all, it is based on a fairy tale. Second thing is, it's a movie. Third thing is, it's actually cartoon characters. It is not real people. Fourth thing is, there are voiceovers. Just, it goes on and on. So, fairy tale is really virtualization. And is virtualization a fairy tale? Because people have been talking of virtualization a lot, and there are many virtualization solutions out there, but it's for anybody to guess whether it's a fairy tale or not. All right, so moving on, when did the history of virtualization really start? When people started drawing maps. Apparently, the concept of maps is about 8,000 years old. It's much older than the concept of writing. And it's considered as one of the fundamental steps in recognizing the modern human being. So this is just a picture of one of the early maps of the world. So this particular picture is from 1300. But apparently the concept of maps started 8,000 years back. And the more interesting part is that the first known maps are those of heavens and not of any earthly places. Some other virtualizations. So simulators, robots, models. So here we have a horse simulator from World War I. So people were taught to ride horses on this simulator. Here is Leonardo's drawing of the helicopter model. And then one of the early flight simulators, wind tunnel, Asimo, the robot, and also the Trojan horse. So virtualization need not necessarily be positive. We could also have Trojan horses in virtualization. So let's move on towards computing. We are all interested in computing. So virtualization in computing. What's the first virtualization in computing? The concept of number itself is a virtual concept. Number is not real. Means people started realizing that 5 apples, 5 oranges, and 5 fingers on the hand have something in common, and that is the concept of 5 as a number. And this is a great step towards virtualization. Concept of 0 is even more important because it's really hard to come by, because 0 is really very hard, nothing. And we should be proud of ourselves because Indians were pioneers in these concepts. Not only just the concept of zero, but the decimal system, as well as first written evidence of rules of algebra and number system, where all that work was done in India. Some more. These are some human computers. Computers were invented for virtualization. It's the concept of computers existed. Taking a problem, modeling it in terms of some mathematical model, and solving that problem in that model, and then applying the solution to real life. This was something there even before computers were invented. So these are some human computers. Earlier, work was actually getting divided, and computation work was getting divided so that parallel work could be done. Work could be done in parallel. And then it was handed over to multiple people for computation. So first known organized exercise was computation of Halley's comets period. So that was such an exercise. So that is there. Then in India, this person, Radhanath Sikdar. He was a human computer. And he is the one who found out which was the height of Everest. At that time, it was not known as Everest. Then the Manhattan Project. You must have heard of great physicist Richard Feynman. He was managing the human computers in the Manhattan Project or the atom bomb project. Well, so virtualization, the in thing that we really want to talk about today. So this is what it is. So what you do is that you have some physical resources, there is some virtualization layer in between, and then you get virtual resources. So you just organize the physical resources with some layer, and then you have you have virtual resources. Okay. So good example of virtualization. Take the stock market. Now I really don't know much about stock market, otherwise I won't be doing software, right? So the stocks, then mutual funds. Mutual funds is a virtualization. So you get mutual fund, that's a virtualization. So the whole idea is to go away or try to go away from physical resources by means of intelligent value add. Intelligent, very important. Intelligence is a necessary and sufficient condition for virtualization. So whenever there is intelligence, there is virtualization, and whenever there is virtualization, you need intelligence to deal with that. So that's the idea. And why do you really want to move away from physical resources? There is one property of hardware and software, the difference between hardware and software. Okay. So somebody told me, and the most convincing difference that I know of between hardware and software is hardware is anything and everything that you can kick. Software is everything else. You can't touch software, you can't kick software. Then there is one more. Hardware eventually fails. There is wear and tear, and hardware will fail eventually. It will go bad. Software eventually works. Once people sort of kill all the bugs, so software eventually starts working. So since software eventually starts working, we really want everything to be controlled by software, okay? Not have critical dependency on hardware. So here are some possibilities of virtualization. They are only limited by your imagination. So you have the virtualization layers in between, you have physical resources down at the bottom. The physical resources need not all be of the same type. They could be of different types, different sizes, different physical characteristics. And then even the virtualized resources, they could also be of different scale, different variety, but they are smoother, they are more uniform, or come out of a mold. Virtualization need not be just one layer. It could be stacked layers. It could be across networks, among networks, within networks. It need not be just one type of resources. You could take whole environments and virtualize them. So there is one on the other side. Or they could be across locations connected by means of WANs. Or virtualization, some of the things that you are available, that you can see as virtual objects, they need not even have corresponding physical objects underneath them. So just some various different types of possible virtualizations. Some early virtualizations. So IBM mainframes and the VM that they used to run can be considered as sort of pioneer virtualization server. You could partition these mainframes. They became very popular because you could partition these mainframes and immediately start different instances of OSS running on them. And the virtualization was so good that VM itself could be run as an instance within VM. And this could go on for multiple levels without any performance penalties. So the code was written really well. And now, even now, the mainframes are still there, and they can these days even run Linux and Java and everything. So it's the most significant virtual server yet, and most robust, I must say. Here is another example. I have taken from OpenVMS. This particular thing is from OpenVMS Galaxy. And this is, even though OpenVMS is a fairly old operating system, this particular concept is from the early 2000s. So it is not very old. This is only 5 or 6 years old. So this is the concept of soft partitioning. So what you have here is that you actually allocate instances of certain hardware resources to certain instances of OSS. So in this case, what you have is that you actually have 3 instances of OSS. So OpenVMS is running in 3 different instances. So these are, for all practical purposes, these are 3 different machines for the rest of the world. But they are actually sharing memory, and they are communicating with each other through shared memory. So the LAN between them is through shared memory, cluster interconnect is through shared memory, and so that access is very fast. The beauty is that they can even reassign the CPUs dynamically. So depending on the load of a particular instance, you can, first of all, an operator can, there is a GUI management utility. You can just drag and drop a CPU from one instance to another, or even you can program the system in such a way that if the utilization of a particular system goes beyond certain limit, it will just try to grab CPUs. Just the way you allocate memory, it will just grab CPUs. So it's a very, very powerful concept. All right, some more about server virtualization. So VMware, you can say, is one of the sort of pioneers of server virtualization, especially for the Intel-based industry standard platforms. So what this thing has is, you really have just one single physical resource, and you can partition that physical resource into multiple virtual machines. And you will see on the bottom there that all the physical resources are actually, images of those physical resources are available to these multiple instances of the OSS as if they are some logical hardware. So that is the beauty. And what you can do is, all of this stuff is actually encapsulated in single file or just a single set of files. So it is very easy to replicate. You can just take the file, copy it somewhere else, and the same configuration is immediately up and running. So those are some of the beauties of this kind of a configuration. Other thing is that you want, okay, I want a machine having so much memory and so much CPU cycles, so much performance, and you can create a machine exactly like that. Then you say, well, I need a little bit more memory. Okay, you can have a little bit more memory. Or what you can do is, especially when you are in some kind of a software development or testing environment, what you want to do is that certain problem reproduces only when the system is, the CPU utilization or memory utilization is beyond certain limits. Then only the problem reproduces. So what you do is that you actually adjust the different parameters in order to reproduce problems. So such kind of advantages are there. So similarly, Microsoft also has a product, Microsoft Virtual Server. It's very similar in nature. The only thing is that Microsoft's product has to necessarily run on top of the Windows platform, and but it is good enough to emulate other or guest operating system, could be anything. And these days, even Intel and AMD, they have come up with special support for virtualizing the machines, because there are some very interesting manipulations that you need to do if you want to handle interrupts and so on from these operating systems. And if you really want to do it the right way, then right now people are finding various different tricks to do those things with the traditional processors. But Intel and AMD have actually come up with support for such kind of virtual machines. And they have some different rings, as they call them, within their processor cores. All right, some virtualization in networking technologies. Okay, networking technology is very rich in virtualization, really, but I am not a networking person. Two things that are very important for my day-to-day activities. One is virtual private network, and the other thing is VLAN. Very, very important concepts, because you can be a part of the VLAN from anywhere on the WAN, and that is something very, very important. You don't have to be physically in the same room. You can be a part of a VLAN from anywhere, and it is still secure. So that is something very, very important. VPN, you don't need to necessarily invest in all those physical cables. And you can just use the public infrastructure, but using appropriate security mechanisms, you can actually form virtual private networks, and you are up and running. It's the whole services business that we have here, that is global, operates because of these two things. All right, moving further, master plan for storage virtualization, and this is by SNIA, or Storage Networking Industry Association. It's also one of the sponsors of SNUG. They call it shared storage model, as well as they prefer to use the term aggregation to virtualization. So these are the different layers that are defined. So at the highest level, you have application, and at the lowest level, you have devices. So you can start with things like disks and tape. Even within disk firmware actually translates the things from the entities that can be addressed from the cylinders, heads, and sectors to logical blocks. In fact, today, the lowest that people really think about, most people really think about in storage industry, are these sequences of blocks. They really don't think anything below that, unless you are just working on designing disks. So similarly with tapes, means tape drives also have fairly sophisticated tape firmware, and you can actually show the tape or view the tape as if it's a very slow disk. It's a bad idea to do so. But it can work in theory. So we have things like virtual tape libraries, where just these are actually emulated using disks, but they fake the characteristics of tapes. So all the tape related software and backup software that is there in the world will keep working. It will just work very fast. So that's the idea there. Block level. Once you have logical blocks, then one very important thing to note is wherever there is intelligence, wherever there is CPU power, people have tried to exploit it and put some virtualization in there. So devices, so right from even disks, as we are saying, So then go hardware RAID. So you have controllers, and that started with striping, and then they came up with parity and whatnot. Then within network, today you have intelligent switches with volume managers and all those things on top of those switches. So within host, LVM, software RAID, all those things are within the OS. So then go up, file level virtualization. So there are some file management appliances out there. Or you have something like a NAS, network attached storage, NAS appliances, or databases. Even you have the concept of virtual databases. You also have the concept of people coming from directories and that kind of a background. There is also a concept of virtual directories. So what you do is that you just have a bunch of different databases, you put some engine in front of them, and it starts behaving as if it is one single database. So that's the very basic idea, and then you can think of all sorts of variations that you can do on these themes. Similarly for directories. So similarly for applications, means you can even start streaming applications from single source. So all of these, this stack is extremely important in understanding of virtualization, especially from the point of view of storage. Even though I feel that as far as virtualization is concerned, it is critical to take a complete enterprise view, and it should not be limited just to storage. Limiting it just to storage is, in my opinion, not the right thing to do. Okay, so here are some pictures of what virtualization is all about. So some pictures, it is not possible to come up with all possibilities. So some interesting ones here are DAS, NAS, SAN. People all know about all these things. So some of the more modern ones are intelligent switches in a SAN. So the switches actually have some virtualization software in there. Or that one is something I find very interesting because it is some kind of a collaborative virtualization. So you have some intelligent HBAs or host bus adapters, or the things with using which hosts or computers connect to the storage area networks, and they actually collaborate with some appliances out of band, so-called. So the communication from the host or the virtualization is not necessarily happening within the IO path. So there is, means the intelligence is sort of outside the IO path. All right, so you must have heard of all these things, snapshots. So point in time copies. So any significant point in time copies. So what you want to do is that end of the day, this is it. It's my office closed, shutter down. So at that time, what was the situation? So you take a snapshot at that time. So whatever was the content of your storage, what was the state of your application, it is actually stored, and it can even be presented. So that's snapshot. So typically people use some technique like copy on write. So what is happening is that when you actually you are actually trying to write to those blocks where the data from that snapshot resides, at that time you copy that data out and put it somewhere else and manipulate the pointers. That is how typically the snapshots are implemented. There are n number of possible implementations. Continuous data protection. So continuous data protection is that suppose you have an application, obviously application requires some data, so there are all the layers of the stack are there. And then what you want to do is that you want to have infinite level undo. You want to be able to go anywhere. So it is very similar to just Microsoft Word. You type in Microsoft Word, you make mistakes, you delete accidentally, everything. Just keep pressing Control Z and you keep getting those things back, right? So similarly, what if you can do the same thing with the application state, whole application state? So you need to keep track of every single, excuse me, every single change that is happening. So that is continuous data protection. And it has the ability to provide images from any point in time. Or disaster recovery solutions, the ability to recover from a significant disaster. Suppose this building goes down, all the computers in this building go down. So it doesn't mean that some bank should just shut its shutters and go bankrupt. So they really need to survive. So they need to have disaster recovery solutions. Many times this is done by site mirroring or something like that. Then wide area data services. Today what you want to do is that you have, your offices are scattered all over the globe, but you have people, first of all, people traveling all over, as well as you have, thank you, you have people requiring the same data, and they want that data to be accessed at LAN speeds. So how do you achieve that? Virtualization, network, have intelligent infrastructure below you. And there are different solutions for all of these things, at combinations of all of these different layers. So applications, host-based management software, clusters, files, file systems, NAS, all of these solutions means this is actually a matrix. So it is not it is not that snapshot has to be at block level. No, means you could conceive a snapshot at all different levels, and so on. Even disaster recovery solution or continuous data protection, wide area data services, you can conceive them at all different levels, sometimes interesting combination of levels, and so on. So that's why virtualization is so powerful, and that is the reason why you really need to understand the master plan for virtualization as proposed by SNIA to really understand or really make full use of virtualization. So some more interesting things. Application streaming. So what these people really do is that I have just found some interesting vendors for this type of products, and I have taken just information about those from their websites. So what the idea here is that when you install an application on a desktop, or rather, let me go back a bit. You don't need to install an application on a desktop. You should not be required to install an application on a desktop to run it. That's the idea. That applications should be installed and managed from a centrally managed place. It need not be central, it can be distributed, but all applications should be managed from a central place, and the clients should just be able to access the applications. That is the idea. They should not be required to install the applications, so that the IT staff doesn't have to go around with every single person saying, hey, I need to update your application, go to the next version and whatnot. Okay. So what these people really do is that they take, especially for Microsoft Windows, what they do is they actually bundle up the application and prepare it for streaming, as they call it. So they virtualize all the system calls and all the system resources that the application requires. Means if it makes some registry entry or it makes creates some files, everything, they keep track of everything. And then they come up with some virtualized cocoon or something like that. And this cocoon is present, so that is how they actually see what way the application is going to be used. And they prepare some kind of a package for an application that is then deployed on their centrally managed system. And then you have only the client parts of this cocoon installed on all the desktops or laptops or whatever client machines. And then you have the applications available. The good part about it is that you still don't have to be connected to the network at all times. You have to be connected to the network only for the first time. And then it actually streams out those parts of the application that are necessary to run. So it doesn't even load the whole application. It actually manages to load only those parts of the application that are being used. And then these are even available offline. So it's a very, very powerful concept, and there are already multiple people implementing this. So there is one more vendor, Softricity and AppStream. So apparently this is now a part of Microsoft. And they also have centrally managed security policies, who can use which software and all of that. All of that is taken care of. Once you have the whole thing centrally managed, you can take care of all of these things. Well, so what is really the goal of this virtualization? Virtualization is cool. We are all technical people, and what we like to do is that just the way mathematicians like to play with numbers and come up with some cool things, solve puzzles and so on. Why is it that virtualization is so important? And why is it that it is not only is it a cool thing to do, but why is it that businesses are interested in it? Why is it that people are interested in putting money in virtualization? Nobody wants to pay for resources that are not required right now. Especially so businesses. Individuals may, means people have this, if you have the means, go and buy a huge house. Means people do that. But you really don't want to do that if you are a business. What you want to do is that you want to, as far as your compute power, storage capacity, networking bandwidth is concerned, you want to pay for only exactly what you require. You don't want to pay for anything more. Let's take the example of my laptop. It has 80 gigabytes of space. I am very liberal about it. I have some movies I have loaded on this because, well, sometimes I travel all over the places, so I have some time, and otherwise I don't get time to watch movies. So why not watch movies? So I have like 50% of those movies have never been opened since 1 year now. I have a lot of music, and again 50% of the music is something I have never listened to. 90% of the music is something I have listened to once, and 10% music is something I keep listening every now and then, very frequently. And even despite of all of these things, I still have 50% of the disk free. So we are really investing so much money in this disk space because I might need to scale at some point in time. Okay. And in the lifespan of my laptop, maybe 2% of the time is when I might want to have full disk full of data. I really don't know. So why should a business require to pay for such resources? It's half the resources go underutilized, okay, or resources are only half utilized. Okay. So that is something that has to change. So people need to be able to, businesses need to be able to go to some virtual IT infrastructure service providers and say, okay, I want so much compute power, I want so much bandwidth, so much storage, that is what I need now. But tomorrow, I might get another customer and suddenly my requirement might go up, okay. I might be required to scale up, so I might require more compute power. I might require more storage, okay. All of that should be available without any disruption. Immediately, on demand. I need it now, so I should be able to get it. Okay, and the scalability has to be very granular. It has to scale right. Okay, and it should be able to scale out. Means I just need more instances of what I have just now, immediately, right now. Okay, I need better RTO and RPO, recovery time objective, recovery point objective. So basically, I need more reliability and higher security, whatever it is. Okay, I should be able to get that from the compute resources. I should be able to add these features without any disruptions. Essentially, what I should be able to do is that just go out and buy exactly what I want today, for today, what I need for today. And if my need changes tomorrow, I should be able to scale it right. And if virtualization is implemented right, this can be done. The goal of virtualization should be this. And that is where people want to go. So it's very, very important to understand, especially from storage users community perspective. This is very important, that we really want to exactly have that much storage that is required right now. I really don't want to invest in any more compute resources that are going to be depreciating. Because the value, even though the resource is unused, the value is going down, right? So, and SLAs have to be there. and the whole thing has to be managed using SLAs. So otherwise, it will be completely chaotic, either within an organization or outside an organization. Means either it could be some service provider like this virtual IT infrastructure service provider, or an in-house IT department. They should be able to provide compute infrastructure services on demand as required and completely transparently. And that can be achieved only through virtualization. So that is where we really are. So that's all I really have. Questions, comments, you are very welcome.